relationship between exponentials and logarithms. So we know powers and logarithms are related because the index laws and the log laws are very similar. And here we're going to look specifically at how e is related to natural logarithms. So if we have y equals e to the power of x, we can use our log definition to rewrite this as x equals ln y. And remember, another way to write ln y is log y base e. So let's draw a number plane and graph these two functions. So y equals e to the power of x is our exponential that goes through 1, and it has an asymptote on the x-axis. So as x gets really, really small, y is approaching 0 there. And if we graph y, so we're graphing, this was y equals e to the power of x, and now I want to graph y equals ln to the power of x. And if we graph that, that's going to look something like this, where this is y equals ln x. And that actually goes through 1. And what you'll find is that they're a perfect mirror image about the line y equals x. And when this is the case, whenever two graphs are a mirror image about y equals x, we call those inverse functions. So y equals e to the x and y equals ln x are just the inverse functions of each other. And what that means is, if we have y equals e to the power of x, let's have a look when we let our input be x equals 0. So when x equals 0 here, we get e to the power of 0, and anything to the power of 0 is 1. So we get y equals 1 as our output. Now let's look at y equals ln x. And this time, let's put our input as x equals 1. So we get y equals ln 1, and the log of 1 with any base gives us y equals 0 as our output. So what's happened is that in our original function, our input gives us a certain output, and then in the inverse function, that output as put as the input gives us the output of our original input.